Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, I welcome all the PG students and CSIR aspirants. Prayer is talking to God Almighty, the creator of whole universe. So let's begin our session with the presence of God, prayer.
நீராறும் கடலொடு நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதிசிறந்த திராவிடனல் திருநாளும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறமிழந்து செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं धृतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Our aim is to encourage all PG and CSIR aspirants to achieve their goal. So make use of it. This is a free online class which is conducted every Saturday and Sunday. Today, our resource person is Dr. K.A. Venkatesh, Professor of Maths and Computer Science, MIIT, Myanmar. Adjunct Professor, IIT Bombay. Dean, Research and Professor of Maths and Computer Science and Engineering, Presidency University, Bangalore. Now, I handed over the session to you, sir.
Good evening to all. Meet you once again. The inauguration day just came in. This is extension of that. It's an ongoing process, so we'll be meeting often. So today's topic, we are going to talk on operation research. So you know what is operation research. Many of you might have studied, or those who have not studied also not a problem at all. I'll be starting from the beginning. This is not going to be only question answer session. This is going to be a little bit of presentation, then some problem solving, then objective type questions. That is a flow I planned it. If you have any specific agenda, please let us know. I'll rearrange my presentation as per your thought. So the simplest reason is you are the end user. Certainly we are trying to accommodate your request. So definitely it will happen. With a small note, I'll go with the presentation. So the operation research, some form you might have studied, since I know the syllabus, either you might have done a small course in your undergraduate program called as linear programming problem, or in the masters you might have done 1 or 2 courses. So this is the general syllabus across Tamil Nadu and most of the universities in India. Operation research as a specialized stream is available. So we have to cover what is possible, what is not possible. We'll try to accommodate. So now, what is operation research, when it is born, all those things, history you can see later part. I'll go with my presentation. So first is, what is the some places this is called as mathematical programming. So mathematical programming, linear programming, operation is a bigger window. There is another name in the other discipline called as management science. So management science is mixture of operation research and statistics all put together. It's a quantitative techniques. So why do you require quantitative techniques? First you understand that part, then model building. On model building, what are the things we are going to take care of that? Then what and all this concept, this OR or management science going to cover? That is part. So I have seen 3-4 years question paper, the previous 4 years question paper. The number of questions may be minimal, but as a subject, I cannot just talk about only questions. So we'll be doing that part. Your preparation is also required. So today itself we'll be seeing it. I'll be posting some questions you have to answer online. Then you can see how far you are doing it. The next session when you come over there, I'll tell you end of the session what I'm going to cover in the subsequent session. So therefore you are better prepared. Any doubt, you can discuss. All those things are possible. That's agenda. Just I'll go with my presentation. So that's one of the good initiatives. So there, the DG Vaishnav College is doing for us. So it's an opportunity for us to learn. For me also, it's a learning experience because this is a different ball game than teaching inside a classroom. So therefore, I'm also learning along with you. So we can feel each other with the same manner, not beyond that. Okay. So this course, how I'm going to cover is body of knowledge. What is this going to talk about that? What are the general techniques used for problem solving? Why we have to solve a problem? To make a decision. Therefore, problem solving and decision making always comes together. So then quantitative analysis. So why we are solving problem solving could be qualitative way also. Therefore, quantitative analysis and decision making. Then what is quantitative analysis? That's what we're going to talk about. Models of cost, revenue, and profit. So this, you should not think it is an economics. It is also part of that. The appropriate model we have to choose, probably it's a cost analysis, or it could be a revenue analysis, or it could be a profit analysis. So whatever it is, so all merged here. Economics, management, mathematics, all. In mathematics, what we do in general, mostly we supposed to do the theorem and the convexity behind the things, convex hull, convex cone, that kind of things we supposed to do. But the syllabus, we are not talking about that level. So some theorems and problem solving. So the CSR question paper is also based on problem solving only. So we can look at that. So management science topics. So you will see that both are one and the same little later. So what is body of knowledge? That's what I said. Management science is an approach to decision making based on some scientific method. And what kind of scientific method? It uses the quantitative analysis. So the quantitative analysis, in the sense, obviously we have to play with numbers and variables. So that is what we are going to call it as quantitative analysis. In addition to that, sometimes we have to look at the underlying distribution. That is a statistical distribution. We have to talk about that. Especially one of the questions there every year they asked is from queuing theory or waiting line models. That time, that is a place we use most statistical techniques. So that is needed. Apart from that, any project management tools you might have studied CPM and PERT, critical path method, and program evaluation and review techniques. So there also there are certain assumptions we'll make. Beta distribution to normal distribution, we have to take all those places we require, but very minimal. We won't no need of worrying about statistics totally. We have to look at that. It is not. So with minimal, we can learn this course better. If you know statistics well, this is going to be a nice thing. So the quantitative approach is nothing but sometimes we call it as operation research, sometimes we call it as a decision science. So whatever it is one and the same with different labels. So if you take a management science book, that is a nice book to see the applications than Taha book. We follow mathematical people who used to follow Taha, or there is a book Kanti Sharoop and T.K. Gupta. That is a book mostly used by many universities. Okay, whichever the book you are using it, this is the best book is management science title. I follow a book called as Anderson and Sydney and others. So 4-5 authors. So that is one of the good books available. Hiller and there is one more author book is available. So you can see any book on management science. So that is what. So the history is known to you. It is born during the World War II. So is it the right time to invent some subject during the World War II? If you imagine it, the worst scenario, we have to identify the best cases. So that is what this. So therefore, even the worst case, how to identify the best one, they did it. Then it followed with the help of computers. Many industries are using it. You won't believe there is an industry called as Jacquemart Textiles in Erode. From a US, 3 management process came and sat for 3 months, and they made a big case analysis from that industry using LPP only. So the application is big. So you have to think over it. What is the application? Can I apply it in my day-to-day life? Yes, it is possible. You have to think over it. So that is the thing, right? So this is the general problem solving techniques. So first 5 steps are the general. The other one is with respect to this course. So when any scenario is given, the first job is how to define a problem. If you are able to understand the problem statement precisely, then it is easy to solve the problem. Therefore, problem is well defined. Then, is there any alternate to that solution, whatever you found? If it is there, you have to identify all possible alternate things. Then you have to find out there are many alternate solutions. How do you choose which is the best one? Therefore, the meeting criteria should be defined to evaluate the solutions. So once you evaluate it, whichever is the best one, you have to choose that. Then once you decided this is the best thing for me, then you have to implement. Once implemented, you have to evaluate then whether it is works in the tomorrow's scenario also. This is the general way of looking at any problem solving. There is a nice book, if you look at that, G. Polio. So that book talks about problem solving in a different way. That is also mathematical students supposed to look at that, right? So this is what I said. Quantitative analysis and decision making. Potential reasons for quantitative analysis approach to decision making. When we do is the problem is much complex and it is very important to solve, and it is never seen by us earlier. And the problem is not one time it's going to happen. It is going to happen repeatedly multiple times. So therefore, you have to solve, you have to identify a nice method to identify the best solution. So this model development is the first part. When you are developing a model, there are some numerical values available there. You have to pick out the right kind of numerical data. After having that model development numerical data, then you will be learning many models. See the linear programming problems, you might have seen that somebody might have seen LPP, then you might have seen that goal programming, then you might have seen non-linear programming or quadratic programming. So many things you might have seen. I know 5-6 methods, which one is right method to solve it? So that is what here we talk about model selection. Report generation is not needed with respect to this case is concerned. So, but as a flow, it is one of the things. So what is model? So it is a representation of the real world problem. So it could be a real objects or a real world problem. So 3 kinds of models known to you. One is exact replica. The other one is it looks like replica, but not totally as it is. So mathematical models are very important. We are concentrating on this last part only. Whatever the given in verbal, we have to convert the verbals into mathematical equations, expressions, or inequality, whatever it is. And at the same time, when you are converting into equations and inequalities, we have to make certain assumptions or statistical distributions so that whatever we are going to solve, it is going to be reliable or durable. So that is very important. So that is what the important things. Advantage of this is known to you. When you model it, it requires less time, not much expensive. We are not involving the real thing. Nothing is going to get damaged or damage is going to happen. So risk is very minimal. So what is the mathematical model? I already said about the cost, revenue, benefit, whatever it is there, supposed to be selected precisely. When you are talking about selling a product, your objective is going to be profit maximization. If I am a buyer, my objective is minimize the cost. So depending on that, the cost and benefit consideration must be made very precisely. So you should be talk about what is needed at that scenario based on the problem side. So because in the marketplace, you can see both. Your objective is different, his objective is different, but both have only one objective. That is what important. That is what we are going to talk about linear programming models based on single objective. So when we come over there, that part I'll talk about that. So the mathematical modeling, those who studied something, we call it as a decision variable. So what is decision variable? So some authors used to say controllable inputs. So that is, I know this is what going to happen with respect to that variables. I can produce this much, but I know what is the profit. The profit also sometimes the cost associated with may vary due to variety of reasons. The labor cost may go up or the transportation cost may go up. Nowadays, we are facing that kind of problem because transportations are not available. Therefore, the prices of essential commodities gone up. So all those things are, you can see uncontrollable variables. Therefore, everything associated will differ. So such models, what we call it as based on the input stochastic process, we call it as that is also we have to do. So once you have the stochastic scenario, how to make it the real way in the sense. So then you have to make certain assumption. I know whatever the cost is going to be, the upper cap, I can fix it up, I can work on that. The bounded conditions comes over there. So always I said our objective is going to be either maximize or minimize subject to certain constraints. Suppose you are going to market to buy certain things. What will you do? So you will buy whatever you want. Suppose you are fond of one more item to buy. By going after going there, you've seen that, oh, that looks nice. Why can't I buy? Even you try, subject to the amount what you have in your hand. That is what the constraint or restriction. You cannot buy beyond what you have. Don't say I have a credit card and all those things. Even the credit card, the cost is much higher. You cannot buy beyond that limit of the credit card. So as I said, so this is what the stochastic part. Mostly we deal with deterministic model. Stochastic process is slightly different. Stochastic calculus is utilized by finance people more often. The entire stock market, Brownian motion, all those things falls into that category. So we are not going to talk about that stochastic model, at least in this course. So that's what I said, stochastic models are different. So now you have decision variables you are solved using some method mathematically. Out of all those things, one is you feel that's the best one. That is what we are going to call it as optimal solution. So this is without the framework of any LPP or anything. Generally, we talk about this way. Okay. Now you have to go to that your poll. Please, everyone, visit the website pollev.com/venkateshka647. I'll give you 2 minutes to answer this question. Participants, please go. It is put on the poll or chat window by our organizers. Please visit, answer it. Are you able to go? Yes, one person is gone, only one response. Anybody else? Any faculty members participating, please encourage this to the other people so that it can happen. No one is selecting no also. Others able to go? Mr. Tirmal?
Yes, sir.
Tirmal?
Sir, I posted, sir.
You posted. You also
Yes,
just
sir, I posted.
put I know so that others
Okay, sir.
also will do that.
Okay, sir.
Yeah. We want two-way communication. The two-way communication can happen through question answer like this. For this, there is no explanation is required. It is yes or no, whether you studied linear programming problem or operation research in your undergraduate program, BSc, or in MSc. Mr. Tirmal, did you answer it? Okay.
Sir, yes, sir. Sir,
you
participants answering in chat box only, sir.
Oh, no,
Sir.
they have to answer. Go to this window.
Yeah, yes, sir. Yes, sir.
Because all questions I'm going to post here, then only we know they are answering it or not.
Yes, sir. But participants answering in chat box only, sir.
No, tell them next questions and all they have to answer in the pollev.com only. Okay, so I'll proceed further. Put a message. Next question onwards, they have to answer there only. Then only we know are they interacting it. Okay.
Okay,
Somebody
sir.
put.
Now.
Yeah,
Okay, sir.
yeah. Somebody. Yes. Okay.
Okay, sir.
2 or 3 people. Somebody is changing that. So this is the way we can see that how many are. This is one of the queuing line problem also. There are two kinds of scenario in waiting line problem. I'll wait for a service. I'll just before the counter. Due to some reasons, I leave the queue. That is called as something. The other saying is there could be multiple servers. I'll be jumping from one server, one line to another line. That is also modeled. So therefore, this all we are trying to relate to our subject. Therefore, I wanted to go with pollev.com. Okay. Thanks for participating in the survey. There are a couple of people said yes, no, it's fine. Yes, people are now working. Okay. Somebody, majority of you studied, then it is easy for me to talk more. Okay, right. I'll go for the next slide. Thanks the thank you the participants. Please, okay, next when you have a questions will come continuously. You can answer it. Now I'll move to the next part. Yeah. So this is the general way of transforming the model inputs into outputs. So uncontrolled inputs are environmental factors. Controlled inputs are nothing but the decision variables. Then appropriate mathematical modeling. The output is the projected result. So this is the flowchart gives the nice idea about how to model this kind of problems. So now the next question comes into picture. This I'm not going to ask in poll EV. So this is a read the question. Consider construction company building a 250 units apartment complex. The project consists of hundreds of activities involving evacuating, forming, wiring, plastering, painting, landscaping, and more. So you know what is the construction work is going on. So some of these activities can be done sequentially, something can happen parallelly, that is simultaneously. So there is also something called as the activity. We cannot start every activity together. Unless until I put the basement, I cannot raise the building. Unless until wiring and plumbing has happened, I cannot do painting. So you know the sequence of activities. One has to happen soon after completion of one. Only the other activity can happen. So now the question is, what is the best schedule for the activities and for which activities additional resources be purchased? So here, what is this problem? What is our objective? I'm not going for the next slide, just we are questioning ourselves. What is our objective? So the company's objective could be, one is maximizing revenue. Is it possible in this scenario? unless until the construction is complete, they cannot sell it under that scenario we are talking about. Therefore, our objective could be project completion time. So when we talk about project completion time, that's supposed to be minimal. So minimal project completion time. So then there are certain things. What are the constraints are possible here? As I said, the precedence relation should be maintained. What do you mean by that? Certain activities are supposed to be completed, then only I can start. There are certain activities parallelly can be stopped. That is fine. So then by seeing after some time the project is going on, then you may think I can speed up my work. How can I do with additional funding or additional equipment, bringing additional equipment to fasten the work? So all those things. So therefore, this model is also going to be stochastic nature. So we don't know what will happen. That can be normalized. I know even if I want to fasten certain activities, what I can do, I can fix a budget. The budget is within this limit. I can try to fasten my activity. So that's an idea of this problem. So you should know what is here, what is the environmental factor is, as I said, when you go for additional work, you are going to fasten the work, how much I can bring inside. That is, or there could be a labor strike, the labor cost may go up. So all those things are possible. So this, you have to think over it and fix it for a framework. With that, within the framework, we have to talk about that. So how much this is what I talked about. Management science or operational research is going to give a scientific approach. So minimum project completion time based on the activities, normal times, then based on the activities, reduced time in the sense we are speeding up, fastening the work. So that is very important. You have to look at that. So what could be the uncontrollable variable? So I said there are certain activities we have to do fasten out. So that when you do that way, the cost also involved, the funds supposed to be available. Even the funds available, when you go for fastening the work, it's not beyond that fund. So other important constraint is, I said, the activity relationship supposed to be maintained in the proper way. Otherwise, we cannot do. So the critical path and all will be using this kind of column. So here, only this, what is the decision variable? Which activities can be fastened up and by how much and when to start each activity. That is supposed to be known. Then objective function is known to us, minimize the project completion time. Constraints known to you. The activity precedence relation should not be violated. As well as whatever the additional funds are available, it should not go beyond that, even though you fasten up your work. So that is what the constraints. So as I said, this model is in general stochastic. We can convert into a deterministic model. So that is possible, right? So that's what I said. Model can be modified as a deterministic one. So this is very important when you are modeling it. The data preparation is very important. Then when you are preparing data, the data may not be accurate. That time you have to do some kind of another arrangements to find out accuracy of the data. Otherwise the model, whatever you do it, it's going to be failure. So this much data. Then information system specialist in the sense when you have a, suppose if you take a project at thermal power plant, the number of variables is going to be 1200. So then how to make a model to run? You cannot find answers easily. Therefore, we need information system specialists. They will say this is the needed, then we can model program it and we can do today. A lot of tools are available. MATLAB gives in one line, Excel solver gives in 3 steps. So we have a lot of tools to solve this kind of problems. So we can do that. So model selection, I said. So this is among all the optimal solution, the best output is called as optimal solution. So then when all the constraints are satisfied, then we say feasible solution. If the constraints are not satisfied, or even one constraint is not satisfied, we'll say infeasible. Then what do we call it as? There are certain things, solutions we have. First is we talk about OBFS. So you know what is OBFS? Optimal basic feasible solution. So still I have not reached that part. So towards that we are motivating now. So model selection, I said the easiest way is by trial and error. I can do that. Then what will happen? It takes more time. Amount of time, money also goes. Time is also gone. So obviously that is not the good one. So we need a special solutions. We can use computer. So obviously, you know the history, how it has come, the simplex method, then Carpenter conditions, ellipsoid algorithm. So many algorithms have come to solve LPP. So this is all can be implemented with the help of computers. It's faster and we can do that. So model testing and validation, I'm not going to talk about that. That can be done. Okay. So this is a nice example. So therefore I put once again one more example. Now, suppose you want to sell your car. So what is the things normally we do? We look at two parameters. One is what is the age of the car, depreciation cost we can put it. Then subsequently, what is the mileage or the kilometerage we run the car. Based on the pricing will go down. So there are certain conditions are given. So the age reduction is $800 per year and mileage reduction is $0.025 per mile. So now we have to create a model. What could be the price, best price? We can talk about that. And there are some probability. Can you assume that I want to say at least 70% of time I'll get this price, therefore I can do some kind of things. So that probability part I've not put here. We can later add that part. So now what is that? The current price, you can fix it up P, then minus 8 into number of years minus mileage into 0.25. That is going to give the best price. So that is what we are talking about, converting this into the model. So develop a mathematical model that will give the starting bid for a car in terms of car original price P, current age and mileage. As I said, you will get P minus 800 A minus 0.25. So the expected pricing is 0.7. So this is a price where we'll get it at any cost. So you can start your option bid. Then people can ask more. Whoever got the highest bid will get this one. So that is possible. So you can start thinking it off. So this is a very simplest model. One can think it off. So this, when the values are given, you fit the model, what is the cost you are going to get. So the model is based on what assumption? So this is only we taken at original price, age and mileage. We are not talked about the other parts. The other part, when you look at the car, today's situation is concerned. You can see that if you go to any particular brand company, how many times the car met an accident, if they done the servicing towards accident, everything can be verified. That part and all not considered based on certain assumptions. So therefore, you should know the things. So this is another nice problem. Here, why you see in general what we do is LPP immediately we start with an objective function set of constraints, non-negative restriction. For that only this problem I put it. Read this problem. So particular company produces two products from the steel. So they have this month quota, some amount of steels. Then product one takes some amount of steels. Product two takes some amount of steel. Then the production level also given, X1, X2 be this production level of product 1 and product 2. So the corresponding profits also given as P1 and P2. The manufacturer has a contract, so he has particular order, at least M units of product 1 this month, and firm's facilities such that at most U units of product 2 may be produced monthly. Now we have to convert as a model. So what you are expecting, objective function is going to be maximize P1 X1 plus P2 X2. So that's the production level we are going to have per unit cost is profit is given subject to the constraints. So what are the constraints you have? Both productions cannot exceed using the steel only P. So less than or equal to B we can write. Then here we are talking about has contract calling for at least M units of product. X1 is greater than or equal to M1 and the firm such that at most M2. So U units of product 2. So at most maximum is only this much we can produce it. So we get this constraint. Now this is what I said, the profit, my objective function is given. Now, so the production is possible is this one. Maximum amount of steel can be utilized as A1 X1 plus A2 X2 less than or equal to B. Then there are two more constraints. X1 is greater than or equal to M and X2 is less than or equal to that. So why here we are talking about X2 greater than or equal to 0? Because when we have this one here, what we are saying at most M does not include the non-negative restriction. So here X1 could be 0 also, non-negative, or we are not going to do anything. That the assumption we make it, but this problem does not explicitly say X1 is non-negativity is required over here. But the scenario compels, therefore we say either we produce or we are not going to produce. You forget about the real scenario as a mathematical concept. You see that, therefore, when the problems are given, tricky problems like this, we'll get like this. when they ask you to model this one, the scenario is given, asked to model it. As in, we are accustomed to write x1, x2 greater than or equal to 0, whereas x2 is about x1, nothing is given. So you should know what is given, how to translate. So where we may slip down because of our practice. So that should be taken care. So this numbers are given. Now you have the where decision variables and all other constraints are given. What could be the model fixed into that? So that is what I put here. So this will get x1, x2 greater than or equal to 0. Now if you solve it, so what we are going to do, model, when you solve it, you are going to get x1 equal to 60 and x2 equal to 62, 626, 2 by 3. So now every product is an engine. So is it possible to produce 2/3 of an engine, which is not possible? Therefore, we put one more restriction. This x1, x2 is supposed to be integer. This leads to another kind of LPP called as integer programming. So problem is solved. Mathematically, we solved x1, x2 values are there, but it is not integer because the products are in engines. So engine cannot be produced 2/3 of an engine. Therefore, it is. So we have to think over it. This is very important to convert. This is again, I captured the information whatever I spoke, right? So this course, what and all there. So here you might have seen certain things. You may not seen some things. I'll talk about that part. You have studied linear programming, integer programming, network models. So network models, you might have studied certain things. The PERT and CPM is also a network model. Beyond that, in the graph theory, you might have studied something called as minimal spanning tree. Then you might have studied maximal flow problems. All comes under network models. That the traveling salesman problem, all can be converted towards network models. Then we can use LPP as a tool. Then I'm not talking about here. Look at anywhere I'm talking about transportation problem and assignment problem. That also falls under network models only. So the network models takes care of that part. PERT and CPM. Then inventory models, yes, we are used to study. Then queuing models or waiting line models we study. Simulation, you may not done it. Decision analysis we might have studied. Then goal programming is multi-objective programming things. After this, you may not looked into it. AHP, analytical hierarchy processing, that is a totally different. This is multi-decision criteria decision making, multi-criteria decision making, MCDM techniques from goal programming onwards. This too. Then forecasting, various methods of forecasting, Markovian process. Some of you might have studied Markovian process. Dynamic programming, you may not look into it. So this is what we have. So in this part, we'll be talking about 3 important areas I'll be covering up. Linear programming includes this also. Network models, everything I'll take under linear programming. Then I'll be talking about queuing models. Those who are really interested beyond that, then I'll talk about PERT, CPM, and inventory models based on the need arises. So this side I'm going to cover it. This side I'm not going to talk about. So this is not required. Here one area I did not cover called as game programming, because game programming, you might have studied game theory, not game programming, sorry, game theory. Game theory is also falls under linear programming, therefore I not talked about, even though you might have studied using different methods, identifying the saddle points and other things. So that can be converted as a linear programming. That's much easier. Therefore, this comes under this category. So this is what we have. So this is introduction to linear programming is now only we reached. So far what we spoke is model, what is modeling, what is management science or linear programming or operation research, what we are going to talk about that. So now we have a base to create any scenario, give verbal statement, convert into the mathematical equations or inequalities. The best way is, that is, if possible, I'll share that document through the organizers. It might reach you by before next week. There could be 100 problems. You just write corresponding mathematical expressions. So that's, if you practice it, it is easy for us. Then the maximization problem. Then how to solve using graphical way. What is the extreme points? We might have studied as corner points or extreme points or boundary points. Then there is a mathematical result. The convexity is preserved. Then we know that the maximum or minima is going to occur only on the corner points or extreme points. So that is what we are going to talk about. Computer solution I'm not going to talk about. One more, minimization and special cases. So this is what we have for today. So linear programming, as I said, linear programming in the sense that we have one objective function that to be optimized. The meaning is either maximize or minimize. That is what we are going to call it as a set of constraints. So why we are calling as linear is limited to the degree which the objective can be pursued. That is what is possibility. That's what we are talking about. What is a feasible solution? A solution which satisfies all the constraints. That is what we are saying. Optimal solution is among the feasible solution which optimize the objective function is called as optimal solution, optimal feasible solution more precisely. Graphical method is we are going to use for two variable problems. So today's discussion is only on that. Now, why it is linear programming? If the both objective function and the constraints are linear, the problem referred to linear programming problem. Linear functions are known to you. You know that what is a linear function is the power of the variable is 1 and anything is multiplied by a constant with power 1 is linear only, or linear constraints could be either equations or greater than or equal to or less than. So that is linear constraints or linear functions restricted to be less than or equal to or greater than or equal to a constant. So the constant normally we call it as right hand side values. So whether the constraints are binding or not based on the right hand side and the sum of the values decision variable solution based on that, we'll talk about that. So for model formulation is nothing but the process of translating verbal statement of a problem into a mathematical statement. So what is the guidelines? So read twice or thrice the problem, understand the problem precisely, define the objective, then based on the scenario, define the constraint for each and every given scenario. From once you identified this two, more or less you are done with, you know the decision variables. So write the objective function in terms of decision variables, write the constraint in terms of decision variables. So this is a general problem, maximization problem is available. You know what is it, you can just quickly solve it and you can find the values. I'm not interested of that way. Here we are going to talk about something different from the usual sense. So normally what we do, to draw a line we need 2 points. Put x1 equal to 0, find x2, and put x2 equal to 0, find x1. You have got the 2 points, draw in the first coordinate. Why we have to go to the first coordinate is because of x1, x2 greater than or equal to 0. Therefore, in the first quadrant we'll draw. We know how it's going on. So now, when you do this thing, then what you do, you identify the corner points and the common region you identify, you call it as feasible region, you'll solve it. Is the way to solve it? Actually, you look at this, there is some equation, objective equation we never used in the graphical method. Am I right? You solve it and among the points which satisfies, you put it in the objective function, we'll solve it. Now, 5x1 plus 7x2 equal to some value. You take that value, move the line towards the optimal direction. If it is maximization, I'll move up towards the corner points till all the constraints are met. One of the places. Why you have to do that? This is going to be parallel lines only. Even whatever the value you take is a constant. 5x1, 7x2 is fixed. So obviously the right hand side is a constant. Some value you are going to get. Irrespective of the values, all the lines you draw they are going to be parallel lines. So this will go. Anyway, I'll explain with picture. That would be better now. So the first line is x1 equal to 6. So we draw a line. Then the second constraint is given. If 2x1 plus 3x2 is less than or equal to 19, as I said, we solve x1 equal to 0 and x2 equal to 0. Obtain the other values, draw the line, got this way. Then the third line, x1 plus x2 equal to 8, draw the line. You have this line. Now all the 3 lines you have. So now you have all the 3 lines nicely. The region, because all constraints are less than or equal to the line, all the regions lies below the line, which common to all the lines is called as feasible region. So that we'll talk about that. This region is feasible region. So now I taken some value objective function. So now I can move up this line or bring it down till it in the feasible region. So one of this will get the objective function maximize or minimize. So that's what we are talking about. So when we move up, see I drawn there. I'll go back to the slide. So 5x1 plus this is an arbitrary value I've taken, drawn a line. Then moving up, because maximization, this when we move up, you are able to see that better values. So when you move there, you're not violated this. So this point, maximization is happening. Therefore, this is the final value. That is a mathematical theorem. Because of that, we never looked at the graphical way. So now prepare the graph for the feasible solution for each constraints. So this is known to you. I'm not talking. The next is again, please go to poll. Now you have to answer one by one. I require your answers, then only I can analyze. The next session will have better way of doing this. So first is, after this, there could be almost another 10 questions I put now based on graphical method, because you know that you can take every question 2 minutes. So first, once you complete it, after 2 minutes, I'll stop that. So 2 minutes is now. There is, you have this. Go to the poll. Please use pollev.com. So you go there and necessary, but I'm giving you 2 minutes. You can answer it. Mr. Trimal, you can post this one.
Yes, sir. Now posted, sir. Now I gave a HTTP link, sir. Directly it will open, sir.
Okay, very good, very good.
Yes, sir. Before they have to type the letter, sir. pollev.com.
No
now I gave
typing.
directly a link, sir. Yes, sir. Now no need to type, sir. Just click,
yes,
then
yes.
they can go directly, sir. Okay.
Yes, let them fill it. Once 2 minutes is over, please let me know. Then the next question I can move. Yeah, looks like people are moving up and down. This is not any democratic election. Please think over it and answer it. I explained the same question in the graphical method. What did I say? Our problem was maximization. Where the line we started in between, where did you find the solution? At the top portion of the place, the feasible region. So what do you mean by that? Move the level profit line up to until no longer intersect with any constraint equation. A is the right answer, not anything else. Please. So now if it is minimization, you have to go down. So that is the next part. So majority of you went to the other side. Obviously, apply the methods of simultaneous equations to solve intersection of the constraints. This is going to give you the C part. Majority of you selected. That is going to give you only the corner points, not anything else. By solving simultaneous equation, it's going to give you corner points. From the corner points, you are tied with the profit thing. So move A is the right choice. 10% of the people did well. Okay, anyway, others will go. Now, okay, it's moving up. So I'll go to the next question. When using a graphical solution, yeah, you send the link again to them so they can join. This is the different link. Same link only, they can go, they can see it. Okay. When using a graphical solution procedure, the region bounded by the set of constraints is, okay, somebody put, okay, nice. So it is, okay. So obviously it is not a solution. So it is not a, see that when using graphical solution procedure, the region bounded the set of constraint is called as feasible region. It is not anything else. So now it has gone up. So it is easy now. So therefore you have to think over it. Then it is easy. The next question, you can see that the corner point solution method can only be used to solve maximization problem. True or false? So I'll wait here for 1 minute. This question not required more than 1 minute. Okay. So interestingly, okay, it's moving up and down. Yeah, this is now corner point solution. What is that? Even if it is the constraints are greater than or equal to what you are going to take in the graphical method, we are going to take above the line and above the feasible region going to get. So obviously, corner point method can be used to solve minimization as well as maximization problem. It is not only for minimization but maximization problem. So therefore, the answer is false is the right one. Corner point can be used to solve both. So you should know that it is not the other way. Majority have done the other side. So please, you solve it minimization problem also using graphical method. Corner point solution is nothing but minimization problem as well as maximization problem only. Now this is immediately you can give the answer. Here we cannot commit mistakes at all. The graphical method of LPP can handle only dash number of decision variables. Okay, 3. Okay, none of the above. Okay, 9, 8. Okay, okay. See, the 3 variable visualization is going to be tougher job. Therefore, which is not possible. None of the above is, if it is, you say, what do you mean by that? Graphical variable of LPP can handle only decision variable in the sense that none of the above meaning that it cannot handle the decision variable problem at all. So it's just wrong. So the answer is only 2. Even I started graphical method can be used to solve 2 variable problems only. So the next question is, types of graphical solution to LPP include all a level or isoprofit line solution, corner point solution, simplex method, all the solutions to the graphic approach, none of the above. Please read the question. Types of graphical solution to LPP include all except other than 1. So yeah, this is I'm giving the answer now. See, the first problem also we have seen that the level profit line we moved up and down, therefore that is required. Corner point solution is going to be one of the corner point solution going to be the optimal solution. All the solutions to the graphical approach is all going to be feasible solutions but not optimal. Therefore, the odd person is the simplex method. The graphical method, how can you use simplex method? So what is simplex? Simplex is nothing but n-sided polygon, which is not required here because we are using graphical method. So the answer is C is the right choice. So all others are needed except C. None of the above also can choose. None of the above if you choose, nothing is there. So one can choose either C as well as D. E cannot be chosen. Only C has to be selected. The next question I'll move. The graphical method uses one objective equation, constraint equation, linear equation, all the above, none of the above. Okay. Why graphical method? Yeah, what is LPP? LPP required objective function, set of constraints, non-negative restriction. So obviously, what is going to become as objective equation, constraint equation? What about the quality of this linear equations? Therefore, all the above is the right answer, not only the objective function constraint equation. We are using linear constraint objective. All this two supposed to be there for all the above. So the right answer is all the above, 56% of 59, 60. Okay, fine. I'll move to the next question. Any LP problem can be solved using graphical solution procedure. Any LP problem can be solved using graphical solution procedure. True or false? Okay. Majority said true. Suppose I have LP problem involving 5 variables. Can we solve? So it is not possible. Therefore, false supposed to be the thing. Only 2 variable problem. Any LP is in the sense that any number of variables, any number of constraints which cannot accommodated by the graphical method. Therefore, the set of solution points that satisfies all of an LP problem's constraints simultaneously is defined as the feasible region in graphical LP. Yes. So true or false? What is feasible region? The region formed by all the constraints, in the sense that the intersecting area, common available area, is called as feasible region, where the solutions lying at the intersection points. The set of solution points obviously satisfies is called as feasible region. So obvious answer is true. So majority you done well. The next is an objective function is necessary in a maximization problem, but it is not required in a minimization problem. Yeah. True or false? Okay, majority said false, obviously, because LPP required an objective function. Obviously, without objective function, we cannot define LPP. So answer whatever you said is majority said is correct. So objective function necessary in maximum term, but is not required is false. So both places is required. Now, which of the following is not a property of LP solution? The presence of restrictions, optimization of some objective function, alternative courses of action to choose from, usage of only linear equations and inequalities. Please read the question. Which of the following is not a property? It is not a I'm not asking is a property, not a property. What are the properties of LPP? The objective function is supposed to be linear. The constraints may be inequality or equality, that is also linear. Non-negative restriction. So these are the 3. So what is here? The presence of restriction is nothing but constraints. Optimization of some objective function, that is objective function thing. Alternative course of action to choose from. Yes, there are possible solutions. Among this, we have to choose the optimal one. Usage of only linear equations and inequality is also true. The left out is the odd man is a computer program. So now it went up. So 44%. So now 50%. So I'll move to the next question. That's all we have questions. Now we have to talk about what is slack and surplus variable. So linear program in which variables are, when you use surplus and slack variables. So I don't want to go for standard form and other things. The constraints when the inequality may be greater than or equal to or less than or equal to. So what do you mean by slack? So something is less to make equality. Therefore, what we are doing, we are adding to make both sides equal. Therefore, it is called as slack variable. Suppose greater than or equal to, what do you make greater than or equal to? Left hand side is more than the right hand side. To balance it, we have to remove something from the left hand side. Therefore, it is surplus. We are removing from the left hand side. So obviously greater than or equal to side. When you write this form, what will happen is all inequalities become equality. Then correspondingly, objective function also we add this variable whose coefficients are going to be 0. So that's what I written as the last line. Slack and surplus variable have objective function coefficients are equal to 0. Now this is an example. So whatever it is, some example. So less than or equal to, here all plus, so less than or equal to this form. So the extreme points and the optimal solution. The corner of the feasible regions are referred as the extreme points or corner points or boundary points. An optimal solution LP problem can be found at the extreme points of the feasible region. So when you are evaluating optimal solution, you have to evaluate only at the feasible points. There is no need of looking at the interior areas. There is an interior point algorithm that not now, well, different time we'll talk about that. So here there are some corner points including that origin. So we have feasible region as given 5 extreme points for that problem. So now what is reduced cost? Those who are familiar with, very good. Those who have done sensitivity analysis, then you may know. Otherwise, I don't want this part. So there are certain things I have to talk about. One, minimization problem, how to solve graphical method. Then there are special cases, infeasible solution when can happen, unbounded solution when can happen. So that part, if I do, more or less I did for today. The next session, what we'll talk about the remaining part. So graphical solution, you know what is a constraint, you do what method. That's what I adopted here, 3 constraints. So here all the constraints are greater than or equal to sign. Therefore, the region is supposed to consider a line and above the line. The less than or equal to case, we have taken line and below the line. Then the common area we chosen. Here it is greater than. Therefore, we have to choose the other way. So when you go that 3 lines are drawn, here I'm not drawing that way. Now we are got feasible region here, the greater than or equal to. So this kind of equations are here. So now you have to find some, as I said, iso line or isoprofit line. You take some value for the objective function, move below this one. You see that towards optimality here minimal. Therefore, we are moving downwards. You can see that the optimality occurs. So minimization, iso line, we are moving down. We'll get something, right? So we got x1, x2, which is going to give us the optimal value. We got the optimal value. The other 2 important parts are not every problem possesses a feasible solution. So some infeasibility is possible. What do you mean by infeasibility? Even one of the constraint is not satisfied by the so corner points, then you can say the constraints are not satisfied with the you assume that there's an optimal value, even though it may give the optimal value for the objective function, but fail to satisfy at least one of the constraint. That is also called as infeasible solution. So this is graphical method, the same thing what we have talked about. So feasible region is known to you. Here we are talking about optimal value. We are not saying optimum. The reason being is we may have more than one optimal solution. Therefore, we are talking about that way. There are some problems you will have 2 optimal values, both equal. So that is the meaning. Then what is the known to you as I said, infeasibility when can happen is, so you have 2 lines, parallel lines. What is a parallel line is known to you. Both constraints, one line is can be scalar multiple of other line. K times L1 is equal to K times L2. Then if you draw that, you may not have intersecting areas. So that time you can say that infeasible. The linear program which over constraint that so that no point satisfies all the constraints that will be infeasible. So this is, look at this, 4x1 plus 3x2 less than or equal to 2x1 x2 greater than or equal to. If you draw this line, obviously you are going to say nothing is common to both. Therefore, no feasible region. Hence, infeasible solution for this problem. Then you have unbounded solution in this case, x1, x2 greater than or equal to 5, 3x1 plus x2 is greater than or equal to 8. It is the region is above this line, so obviously it is unbounded. So now we have to talk about a little more. One such thing is, here we talked about optimal feasible solution, but optimal basic feasible solution. What do you mean by basic solution? When we know set of simultaneous equation, when we are solving, we never called as basic solution. We just called as solution. What is the difference between these two is, there is, please believe that for rectangular matrices also we can find inverse. So believe that using that scenario, now you see your LPP, you might have seen the number of variables is more than number of inequations or equations. So what you do, first you set certain variable 0, solve for the remaining variable, will obtain certain solutions. Such solutions are called as basic solutions. In general, you take 5 variables in 3 equations. How many basic solutions are possible? Those who are interested can put on the chart window your answer. I'll repeat the question. You have 5 variables in 3 equations. How many basic solutions are possible? So that what you do, 5 variables, 3. So 5 minus 3, 2 variable you set as 0. Initially you set x1, x2 equal to 0, then solve for x3, x4, x5. Next time x1, x3 is 0. Solve for the remaining. Third time x1, x4 equal to 0. Then x1, x5 equal to 0. Then you go for x2, x3 equal to 0. x2, x4 equal to 0. x2, x5 equal to 0, x3, x4 equal to 0, x3, x5 equal to 0, x4, x5 equal to 0. If you look at this, what we are doing, we are doing 2 variables at a time 0, or what we are doing is 2 variables 0, we are solving for 3. 3 equations are there, 3, or if it is more. So what we do is, looks like you are choosing R objects from N objects. This can be done in NCR ways, combination. So if number of variables is more than number of equations, say n variables in m equations, where n is greater than m, the number of basic solutions, possible solution is NCM. So that will come. Then we can talk about convexity. Well, so if you've seen the book by linear programming by Hardy, you can see that such problems, we can use those problems also. But the subsequent class, I'll be talking about some questions. I'll start with some questions on the graphical solutions. See here, look at this problem, x1 plus x2 is greater than or equal to 5. Suppose I have here one more constraint like this, 3 less than or equal to x1 plus x2 less than or equal to 10. So how will you do? This is called as bounded variable way. 2 constraints you have to make it and you have to solve it. So that is the difference. So the next session I'll be putting such problems. So then next week when I meet you, I'll start with 5 questions based on graphical method before I move to the next model. The next model I'll go with waiting line models, queuing theory. Then we'll come back to the other parts, linear programming. So graphical method is one of the standard questions in CSIR. Then queuing theory, I'll cover this too, then we can go back. So graphical method, what are questions given there, you can solve without any difficulty. So I stop here. Any questions, please put it on the chat window, then I can request the coordinators to read for me. We can work on that. Mr. Tirmal, kindly help me.
Sir?
Now I stop here for the questions.
Okay.
Today's session is over. Any queries they have, I can have
Okay, sir.
questions now.
Okay, thank you, sir.
Yeah. Any questions?
Thank you, sir. Questions, please, sir. In chat box, no more questions, sir.
Okay. Okay, thank you. So next week we'll be having full-fledged 1.5 hours to 2 hours. We'll have it.
Okay, sir.
Yeah. Thank you. Thank you so much.
Thank you, sir, for your wonderful session. Actually, this online question answer session is very interesting, sir. This is new for us. Okay.
Yeah, that's the reason I want to introduce this to every one of us. All of us can use it. It is free only.
Okay, sir.
Yeah. You have to register and you have to insert it. Yeah, thank you.
Okay, sir. Thank you, sir. Thank you, sir, for your wonderful session again.
Thank you.
Dear participants, tomorrow we have a session at 11 a.m. Resource person, Dr. M. Maruday. We will meet on next session.
Thank you. We will meet next section on tomorrow 11 a.m. Thank you, students.